Hi, welcome to the session, which talks about progressive delivery, experimenting with features in production while minimizing risk. My name is Arit Lewinsky, and I'm a group product manager at Gitlab. Below, you can find my Twitter handle and my direct email address. I'll really appreciate any feedback or comments that you have regarding this presentation. As I mentioned, my name is Arit Lewinsky, and I'm the group product manager of the managed stage at Gitlab, and I'm also an ambassador at the DevOps Institute. I also hold a BSc in computer engineering and an MBA in business, specializing in data systems and cybersecurity. Previously, I was director of R&D infrastructure at Cellebrite, and part of this position was to lead the DevOps department, where I really found my passion for DevOps and specifically for CI/CD. Before that, I also helped to transition teams from waterfall to agile. And previous roles that I held include director of QA, director of product management. I am also a mother of 3 girls, and I'm a certified pastry chef. Okay, so let's start with continuous testing. And so most of us are familiar with the DevOps icon. It's an infinite loop going from different stages in our development. And continuous testing is part of continuous integration. And it's located in the verify stage of the DevOps workflow. And it comes right after the build phase. And those artifacts are tested and verified, and they're approved before moving forward. We're going to talk about in this presentation a little bit about the testing phase, but also testing in production, which is already in the release phase. In terms of the CI/CD pipeline, we're going to talk a little bit about tests, and we're going to talk about the different environments, staging, production, and releasing the artifact. When we talk about challenges for testing, there's a few challenges that we have, and I want to talk a little bit about them. In general, everyone accepts the fact that Agile and DevOps are all about change. Everything is continuously changing, and transforming DevOps is transforming people and processes and technologies to deliver innovative software as rapidly as possible. And in spite of all this change that we talked about, one trend seems to remain the same, and that's software testing and the software testing process. One recent study that I read reported that 70% of the organizations have adapted Agile, but only about 30% of them actually have automated testing in place. In other words, the testing processes remain stuck in the past, even as organizations invest considerable time and effort into transforming their development processes to meet today and tomorrow's business needs and demands. Most legacy software tools and processes are unfit for the type of continuous testing that Agile requires and DevOps require. So one of the main problems that we have is the inability to shift left. And that's purely because testing usually can't be implemented until a late stage in each sprint, when the UI and dependent components like backend and APIs and so are finally complete, or at least in place in order to be tested. Another problem that we have in testing is slow execution time. Tests are really time consuming to execute, and it's not really practical to run a complete suite of regression tests on every single build. And it means that the teams lack instant feedback, and feedback is an important word that we're going to talk about, and whether the changes impact any existing user experience. Another challenge that we have for testing is high maintenance. And to put it simply, UI tests require considerable amount of rework to keep up with the pace of the frequent changes that we have. And this results in really slow and burdensome test maintenance. And it causes the fact that test automation efforts are often abandoned, even if they have started. And the last challenge that I want to touch upon is test environment instability. And this is because test environment instability, which is inaccessible dependencies or test data issues or different kinds of testing problems, are a common cause for timeouts or incomplete tests or false positives or inaccurate test results. And that prevents delivering fast quality feedback that Agile and DevOps require. Now that the Agile practices have matured and DevOps initiatives have entered the corporate agenda, continuous integration, continuous testing, and continuous delivery have emerged as key catalysts for enabling quality of speed. Of the three, continuous testing is by far the most challenging. And so we mentioned continuous delivery. I just want to give a quick recap of what this means. Continuous delivery is a software development discipline where you build software in such a way that software can be released to production theoretically at any given time. You can achieve continuous delivery by continuously integrating the software done by the development team, building executables, running automated tests on those executables to detect problems, and you can push those executables into increasingly production-like environments to ensure that the software is going to work as expected in production. So on top of the continuous delivery concept, we're going to talk about progressive delivery. And James Governor, the founder of Redmonk, put forward a term called progressive delivery at QCon London in 2019 that ensures the strength and flexibility of a system through numerous creative experimentations. So just reading out loud what the slide says, progressive delivery is continuous delivery with fine-grained control over the blast radius. And the idea here is that we all want to ship faster in smaller increments, and we want to explore a way to expose the new functionality with being able to control who is actually going to access that, who is actually going to be exposed to this new functionality to make sure that it is working properly before we expand the audience that is going to get these new features. And this includes testing in production. So one key component that I want to talk about before we talk about production is production-like environments. And at GitLab, but also in other companies, there's a concept called review apps. Review apps, what they do is they provide an automatic live preview of changes made in a feature branch. What they do is they spin up a dynamic environment for your merge requests or pull requests. So this is really based on the change of that specific branch. And it allows people to collaborate on this new environment. So it can be designers, it can be product managers, and they can see the new changes to the code without needing to check out your branch and run your changes in a sandbox environment. It really gives you a production-like view that's really spinned up with a URL and doesn't require from anyone to actively do anything to view these new changes. So it'll give you really a look at what it would look like in production, and people can comment and contribute and give you feedback before this is actually pushed to production. And that's really the strength of it. We have also ability to use visual reviews that let you write to your peers, even to your customers, and ask for direct feedback in your review app so that anything can be fixed before it is pushed to production. So what this looks like in GitLab is this. You can see directly on your merge request itself, you have here a link to the review app. You can press a button and it just directly takes you to that URL. No requirement needed for anyone to do anything external. You can send this URL by email and people can just take a look and let you know what they think. And this is opposed to in the past where a developer may call someone to take a look over their shoulder to see the environment on their laptop, or having this really complicated sandbox environment that you would need to pull and push the branch into and build up your own environment. This is really simple and it can be used for anyone on the team, even if they're not super technical. It can also be used for demo purposes, which is also really great because you can give this to sales or marketing to show your customers. I mentioned that in the past, I managed QA teams, and the notion of testing in production when I was a QA manager would have given me nightmares and kept me up at night. The idea that someone or something could somehow impair or taint the database data on production would really leave me sleepless. But in reality, there really is no better way to check a release post-deployment than on production, because every environment that you build is not going to be exactly the same as production. It may be costly to create a specific production that's exactly the same, or maybe the test data is different than the real data. To really know that something's going to work on production, you actually have to deploy it to production. In the past, when we try to do production-like testing on staging environments or pre-production environments, there was always some kind of nasty surprise that would surface when we actually deploy to production. And so today, testing in production has become a more common practice. And I'm saying this really in a really safe way. You need to make sure that you can deploy to production, but make sure that it's controlled and monitored and that you can really know exactly who is being exposed to this, get really good feedback. And if some catastrophe happens, you have to have a really nice way to roll back. So developers and testers alike have learned to trust their deployments and safety nets found in the development pipeline. And this is really the baseline for enabling testing in production. So up until now, we talked about testing as part of the development and continuous integration tests phase. Now I want to talk about the deployment phase and testing in the continuous delivery phase and really testing in production. So the first advanced deployment method that I want to discuss is called the Bluegreen deployments. And the idea in Bluegreen deployments is that you deploy to two different environments. Blue is the production environment that is exposed to users, but development continues on the green environment. And once development is complete and people are ready to go, you simply swap the two environments, and now all the user traffic is routed to the green environment. So then this is like a new production environment that's on the green, and now all the development is going to continue on blue. So it's really swapping two environments. One is always going to be production, and one of them is always going to be the development side. The biggest downside that this methodology has is that if something goes wrong and something is wrong in your new production environment, the entire development has to be rolled back and swapped back to the blue. And you can't really pick and choose the faulty feature or turn it off. Everything has to be rolled back. On top of the blue-green methodology, there's another concept called Canary releases. And the idea of Canary releases is that you start with, very similar to blue-green, you start with all your machines or Dockers or pods at 100% of the current deployment. So that's the blue deployment. And when you're ready to try out your new features, your new development, you want to run this on a subset of users. That's going to be your experimentation group. Let's say we want to expose the new functionality to 2% of the users. So in an example, if we had 100 machines, 2 of the servers are going to get the new deployment and 98 are still connected to the previous production deployment. So we're going to send 2% of the population to the new 2 machines. And in order to send that 2%, you're going to need to figure out some logic somewhere to figure out how to route those users. And you're going to need to decide whether or not the user routing decision needs to be sticky, meaning giving a consistent experience to that same user. You probably do want this consistency, but you may not want to. And now what you want to do is you want to pay close attention to how those servers are behaving, how they're doing, if they have any errors, or if they have any performance degradations and so on. And what this does, it gives you immediate feedback on our new functionality or on our new behavior, and it allows you to make a conscious decision whether you want to continue deploying to additional users, additional servers, so from 2% to 10% to 15% and so on until you reach 100, or if something goes really wrong and you see some performance problems, you just drain that traffic back to the previous deployment and fix whatever you needed to do. And really, you have contained the problem because you didn't send it to 100% of the users. You send it to a small subset. You got feedback that something was wrong. You drained the traffic back, and the majority of the users didn't even know that something went wrong. Very similar to blue-green in the sense is that if there's a problem in development, you have to drain back all the traffic on those servers. Yes, you didn't expose this to all your users, only to a subset, but still those specific users are going to see that change, and you're going to need to roll back the entire development and not only the faulty one. So I just wanted to show what Canary releases look like in GitLab. And what you can see here is that you can see here the new functionality of the new pods that were deployed in new containers, and as opposed to the old ones. And you can see the different rollouts. So you can see this is 59% with the new development, the new deployment on production. While staging, you can see the test had completed successfully. All 100% of the pods rolled out to the new deployment, whereas in the production environment is going much slowly. It's controlled, more controlled, and you can really get the feedback. And you can see green means everything's okay and we can continue rolling out. You can also see that in case something was not green or there was a problem, you can hit either the rollback button or abort will stop rolling out the new pods, and rollback will obviously drain the traffic back to the previous deployment. Right, so we talked about Bluegreen and we talked about Canary. I want to introduce the concept of feature flags now in our conversation. And feature flags can be used as part of software development to enable a feature to be tested even before it's complete and ready for release. So a feature flag can be used to hide, to enable, or to disable a feature during runtime. And this is a big change from what we talked about in Bluegreen and Canary, because this is done in runtime. So you can change the logic behind it at any given moment, really. The unfinished features can be hidden or toggled so they don't appear in the user interface, but they're still part of the code base. And this is a big change. It allows many small incremental versions of the software to be delivered without the cost of constant branching and merging and so on. Really, when you think about it, feature flags work as an if or else condition inside your code. Some users will match the criteria and some will not. Those that match the criteria will get the new functionality, and those that do not match the criteria will still see the same functionality that they saw before. So this is very similar to Canary in that sense, where it allows you to get immediate feedback for your new functionality. And once you gain confidence, you can increase exposure to additional users, into an additional audience, additional subset. And if something goes wrong, then again, you can just turn off that feature flag and they won't be able to see this faulty feature. A really nice benefit that's gained from using feature flags is that the rules for the condition can change on the fly at any given time. So this is really the strength that on runtime, you can decide that subset A is going to see the feature. And if you see everything's fine, you just change that to A plus B. And then the additional users will see it next time they log in. So as I mentioned, feature flagging is basically Canary for features. It allows you to roll out features gradually, slowly exposing those features. And if something goes wrong, you can confine the feature to either a smaller audience or to different environments. And it still lives in production. So your testing is still done while that feature is in the code base, but it can just be turned off and not appear in the interface. So that's really, really great. And you can see here before and after in the slide. So before we had all the users very similarly to Bluegreen Canary on the old deployment. Now, when we're moving to the new deployment, basically we can just take the exact same deployment as before, but now develop all the features behind a feature flag. So if I turn all the flags off, it's exactly the same as the old deployment. And if I can turn them on slowly and get feedback and decide whether or not to enable that for everyone, then at the end of the day, this feature flag is going to be enabled for all the audience, for all my users. This is what feature flags looks like inside of GitLab. And you can see that feature flag supports several different strategies like %rollout, which is very similar to Canary, user ID and user lists, which allows you to define specific users or groups of users that will either have access or will be denied access to this new functionality. And you can even apply different flags and strategies for different environments. And you can set multiple strategies per environment. And you can play around along with this. And this gives you a lot of control and flexibility on your feature development. The feature flag dashboard here gives you a high level view of exactly what is active and what is not for each flag, exactly for which strategy and which environment. So I want to kind of explain a little bit about the %rollout strategy for feature flags. And feature flags, as I mentioned, work like a condition, like an if and else inside your code. So some users will match the criteria and some will not. And what you can see here is that I decided to roll out my feature for 10% of the users. Once I see everything is great, then I can increase to 30%, then I can increase to 50%, 70%, and so on. And it really gives you control over the feedback that you get and deciding on how you're going to map the rollout of this specific feature. So what are really the differences between feature flags and Canary? Because there's a lot of similarities. So I would say the first one is where they're placed. Canary is really in the infrastructure networking layer. You need to figure out how to drain traffic to your server, to your website, to whatever. And in feature flags, it's really on the application level. As I mentioned, this is done in runtime, so it gives you a lot more control on your rules and granularity. The person or people who are responsible for the rollout on the team, usually when we're talking about Canary, it'll be people who are more involved in the infrastructure layer, networking layer, so DevOps engineers, SREs, and so on. Whereas feature flags, because it's on the application level, it really is much easier to maintain and control. And so really anyone on the team can do it. It can be developers, it can be product managers, it can be QA, it can be support, it can be really anyone on the team. Whitelisting or percentage of users or traffic is supported in both. Rule-based is a really nice difference that I want to explain a little bit. Because feature flags are on the application level, the rules that you can set for your users are really based on your application. So if, for example, we have, I don't know, application for song management, and you want to enable a specific feature for people who are mass users of this feature. So you want to segment users based on, let's say, how many songs they have in a playlist, and you want to enable something for anyone who has over 1,000 songs in their playlist. You can do that on feature flags because it's in your application. You can use anything to read your application logic. When we're talking about Canary, because it's traffic-based, you can't really use the logic of your specific application in order to segment users. It is more based on geolocation, domain, IP addresses, and so on. Same goes for group-based, very similar to what I explained. And the biggest difference, which I think is really important to understand and to remember, is the rollback. So in Canary, you have to roll back the entire development that you did for this specific deployment. It is not like you can just turn off a faulty feature. And in feature flags, you really have a lot of granularity and control, because you can just simply turn off one feature that was giving you problems and still remain with the majority of your new deployment, so users can really benefit from the new functionalities. A concept that I've seen growing now in the market is combining feature flags with Canary. And combining feature flags with Canary really allows you to get the best from both worlds. You can deploy, for example, Canary releases with all the feature flags turned off, and then monitor to see if the Canary is behaving properly. So you're going to monitor for errors, for performance degradations, and so on. And once you're confident that the Canary is okay, you can start turning on very slowly feature flags one by one, gather feedback, see that everything is okay. And then you can increase exposure. And if something is not behaving as it should, you just turn off that specific flag. You don't have to roll back traffic. And it really, really gives you maximum control. So still on the subject of feature flags, because it's semi-related, is the topic of A/B testing. And A/B testing is really an extension of feature flags. It allows you testing of variables of different groups and data and monitoring, which is a preferred method. So unlike what we talked about, feedback of feature flags related to if it's working properly, if there's no performance degradation, and so on, what you want to test here is really how users are interacting with your new functionalities. Let's take, for an example, a website that wants to increase sales, and they want to check whether a workflow that they created in their website is going to result with users adding more items to their cart. Developers can experiment with different user flows, each one sending the user through a different route in their website UI, and monitoring the website for some time, let's say 2 weeks, a month. You can determine the time and see which flow resulted in the most revenue or the most additions to cart. And after the experiment ends, that's going to be the chosen workflow for all the users. So not only the control group and the experiment group, but for all users, that's going to be the business decision on leaving that specific workflow turned on. It's really, really an efficient way to test changes of usability. And based on the test results, which in this case is really revenue, it's a business goal. It's not necessarily performance or development oriented. It can also be better performance, customer engagement, and so on. This really gives you a nice way to interact with users and to see how they're interacting with your new flows. And this is really interesting because it also brings A/B testing to not only the development teams, but also to marketing teams, to sales teams, to growth teams. It really has a really nice advantage of interacting with development flows together with user feedback. So we talked a lot about our different ways of progressive delivery and continuous testing. And I want to kind of discuss the pros and cons. Pros is the ability to control their feature distribution. You can decide which segments are going to get the feature and really monitor to see if it's behaving as you want it to. In case of a failure, really a small group gets exposed to the failure and not the entire audience on production. It gives you the ability to test on production before rolling out to all users. So you can enable something on production, only enable it for your QA team internally or just for a specific beta group and so on, and really collect real feedback on it. Fast feedback and metrics for new features gives you a really quick way to handle failures and get a hold on it before it kind of explodes in production. Because it's very simple, more roles on the team can manage new features in production, and it lets you fail fast. So really fast rollback if needed, because you always have either option to turn off the flag or to roll back to the previous environment that's sitting there waiting to see that everything's okay. And let's talk about the cons. So you can see that the list here is much smaller. One of the cons is the need to monitor latency, traffic, errors, and saturation, which adds a little bit of complexity onto your development. But on the other hand, it also lets you act fast in case of failure. There's a lot of monitoring systems out there that create notifications and trigger auto halt or auto rollback in case there's an error. So thinking about integrating one of those can make this simpler. It can introduce tech debt. Introducing feature flags really introduces additional code, because this is an if or else. Now you need to introduce the else. And also you need to be really aware of the fact that you need to remove feature flags on time and not leave stale code in your code base. So it can definitely introduce tech debt. A mitigation to put in place for that is to enforce a really clear process and state when to remove or auto remove flags from your code. And another code is that it adds a layer of complexity to understand customer scenarios. So let's say someone has a bug and they call customer support and they tell them something in the UI isn't working correctly. It adds a layer of complexity for the support engineer to understand what exactly this customer is seeing, because not all the customers are seeing exactly the same interface. They need to figure out what configuration they have and how to solve the problem. And the mitigation for this would be to add configuration files or breadcrumbs so that it's easier to understand what the customer is looking at. We talked a lot about the different advanced deployment methodologies and feature flags that we have. I want to sum up this session. So concluding, when you want to test in production, it's important to monitor the system and to have an easy way to roll back. The different factors of progressive delivery are environments and users. When controlling environments, developers can deliver features progressively into environments to limit exposure when new code is deployed. When done for users, users are segmented in some way. It can be arbitrary, like percentage, or by a specific identifier, which could be a domain if you want to test things internally, or it can be by specific user mentions or groups, like tier, like if you want to enable a feature for premium users and so on. The developer delivers changes progressively, which means that it's exposed to only that subset of the users. And what's really important is the feedback loop and making a conscious decision whether you can continue to roll out or if you have to roll back the changes. When we think about this change in state of mind, even the ownership of features in production changes. Originally, features were owned by the engineering team, and now once a feature hits production, ownership moves to release managers, product managers, customer support team, who are closer to the customers and are closer to them to get the feedback that is needed. And what this does is it frees up more time for developers to work on newer developments. I want to thank you for listening. As I mentioned, I would be happy to get any feedback about this, questions or comments. You can email me at ogolowinski@gitlab.com or go_read is my Twitter handle. And I hope you enjoyed this presentation.